Hi, this is Anna McCullum. Thanks for attending this session on tackling alert fatigue with event compression and dynamic runbooks. For today's session, we'll start with our overall solution for managing alert fatigue. Then we'll dive into two key parts of our solution, using event compression to reduce overall incident volume and the use of dynamic runbooks to provide a systematic way to manage incidents. Then we'll provide links to additional resources on these topics. As monitored systems and enterprises grow, alerts can also increase. This can lead to alert fatigue if your workload increases, but your ops team size does not. How do you work smarter instead of just harder to manage all of these alerts? Our solution is threefold. First, identify which alert or event is truly actionable and create incidents for these events. Next, consider compressing correlated events into a single incident to reduce the overall volume of incidents you need to manage. Third, capture subject matter expertise or best practices in resolving incidents into dynamic runbooks that can be made available to your ops teams so that they can more efficiently triage and resolve incidents in a streamlined way. Now let's get into details of these features. Let's start with event compression. Event compression focuses on reducing overall incident volume by compressing or grouping related events into incidents. To set it up, you'll use a combination of event compression policies and incident rule sets. An event compression policy identifies what set of events should be grouped together and how they should be grouped together. For example, you may want to group together all target down events from all rack instances that belong to the same rack database, or group together all agent unreachable events from targets managed by the same agent. We provide some out-of-box event compression policies for common event scenarios which you can immediately use. And you can also create your own compression policies to meet specific compression requirements. Event compression policies don't work alone. They need to be invoked by actions in your incident rule sets. So in your incident rule sets, identify the events you're interested in and also include the action to create an incident and use event compression policies when creating the incident. Let's walk through how these work together. Let's say you've defined your event compression policies or are using Oracle's provided event compression policies. You've also created an incident rule set on your production group. In this rule set, you have a rule where you've chosen all target down events and you have an action to create an incident and use event compression policies. Now let's assume you have 3 target down events that have triggered. It will match your incident rule set where the action is to create an incident for these events. Since it also indicates that event compression policies be used before it creates an incident, it will first look at the event compression policies to see if there is an applicable policy. Assuming it finds a matching policy, it will use a policy logic to correlate and compress the events into one incident, so you'll end up with one incident with 3 events instead of 3 incidents with 1 event each. Here's a set of out-of-box compression policies we provide. You'll see a policy for target down events for a rack cluster database, a policy for availability events for an Exadata machine, a policy for agent unreachable events for targets monitored by the same agent. The screenshot on the right shows you the action part of an event rule in an incident rule set. Here we see the option to create an incident and also use event compression policies when creating the incident. So to recap, in order for event compression to occur, there needs to be an applicable event compression policy and a rule for these events that includes the action to create an incident with event compression policies. After you've enabled compression and multiple events are being compressed into an incident, in Incident Manager, when you are reviewing an incident, you can also see the events that were compressed together in the incident. It also shows the specific event compression policy and incident rule set that were used for compression. Now let me show you a demo I recorded earlier on creating and using event compression policies. This is a demo of creating and using event compression policies. We start at the Event Compression Policies page, where we have a set of Oracle-defined and user-created policies. Let's walk through the creation and use of a new event compression policy. Clicking on Create New Policy opens up the policy creation page. In our demo, we want to compress target availability and metric alert events for coherence targets. We give the policy a name and a corresponding description. In this next section, we define the compression logic. First, we identify the type of events, and we choose metric alert and also target availability. Next, we choose the target types. Here we choose our coherence target types. Then we define the event severities associated with these events. In this time window section, we identify when the events occur in order for them to be compressed. Here we want the events to occur within 60 minutes of each other to be considered for compression. Next, we specify how we group the events. Here are the different grouping options, and we keep this first option, which is the same ancestor target type, which really refers to having the same parent or grandparent or other great-grandparents. Then we choose the grouping type, and in our group type, we choose the coherence cluster. This means all events from coherence targets that belong to the same coherence cluster should be grouped together. We keep the default incident message and click Save. Now we enable the policy and confirm that we want it enabled. Note that it's still in draft mode, so it's not yet available for general use. Before we make it available for general use, we want to first test our policy using Event Compression Analysis tool. This tool allows you to review the effectiveness of event compression policies against your events by simulating the creation of incidents with your event compression policies. You'll then be able to compare these simulated incidents with incidents that have occurred without compression. Let's start a new analysis. We first give it a name, and in the targets list, you can give it a group or a set of targets whose events you want to analyze. Let's keep group and also choose our coherence targets group. Next, you specify the range of dates on which the events occurred, and also click on the Include Draft Policy because we also want to test our newly created policy, which is still in draft mode. Now we can start the analysis. It creates a job to do the analysis, and after a few minutes, it is completed. Let's see the results of the analysis. Here we see it analyzed 30 events for the time period that we specified. Without event compression policies, we see 30 incidents created, and with compression policies, we have 10 incidents, resulting in 66% fewer incidents and an average compression ratio of about three events per incident. At the bottom, we see a timeline of when the events occurred. The blue bars show the number of incidents without compression, and the shorter orange bars show the number of incidents with compression. You can click on any of these bars to show you the details of the events. Here we see each gray line corresponding to an event, and then the lines in blue represent a single incident, and we see these incidents contain one event each. We also see the grouping or the compression of several of these events into a single incident represented by the orange bar on the left. Now that our event compression analysis has shown us that our policy is effective, let's go back to event compression policies and publish it. With our policy published, now let's make sure we have our incident rules set up to use the policy. Let's navigate to the incident rule sets. Here's our incident rule set that we pre-created to use the policies. Let's select this rule and edit it. Scrolling down, we see two rules, one for target availability events and the other for metric alert events, both with the option to create incidents and use event compression policies. However, since we want to compress both event types, target availability and metric alert, we choose this option to compress events across event types from multiple rules. Scrolling up, we save the rule. Another use case for event compression is in the area of handling agent unreachable events that could trigger if there are network outages or connectivity issues between the OMS and the agents. If that occurs, then you may see agent unreachable events on the agents, hosts, and all targets on the host. To manage these events, first you can set an OMS property shown here to prevent the generation of agent unreachable events for all non-host monitored targets, such as database, listener, WebLogic server, etc. Once the property is set, then agent unreachable events, if they trigger, will only trigger on the host and agent targets. Next, use event compression policies to compress agent unreachable events for your agents and hosts. There are different ways you can set this up based on how you manage these incidents. For example, if one team manages all of the hosts and another team manages all of the agents, then create one event compression policy to compress all agent unreachable events, which are target availability events, across all hosts into one incident, and create another event compression policy to compress all agent unreachable events across all agents into one incident. Make sure these policies are ordered ahead of your other event compression policies so that they take effect first. Here are additional considerations for compressing events. First, the order of your policies and incident rule sets matter. If you have a set of incident rule sets, they will be evaluated against incoming events based on the order you specify for the rule sets. The same is true for event compression policies. When Enterprise Manager tries to find a matching event compression policy for an event, it will look at the first policy, then the second policy, etc., until it finds a policy that matches the event. Hence, if your events aren't compressed as you expected, revisit the order of both your incident rule sets and event compression policies. The second consideration is the scope of targets in the incident rule set. More specifically, the set of events that are eligible for compression are based on the targets in the incident rule set. Going back to our agent unreachable event scenario, let's say you have an event compression policy that compresses all agent unreachable events on host targets. Let's say you also have two incident rule sets, one that applies to your production group and another that applies to your non-production group. When the agent unreachable events are triggered, then if they are associated with a host in the production group, they will match the target's criteria in the prod rule set and hence will be compressed as part of incident 1. When the agent unreachable events are triggered and these are associated with a non-production host, then they will match the non-prod incident rule set and will be compressed as part of incident 2. Now let's talk about dynamic runbooks, which is another key part of managing alerts. Dynamic runbooks enable subject matter experts to capture their best practices procedures in managing alerts or incidents in the form of steps that can be executed in Enterprise Manager. While we will discuss its use in managing alerts or incidents, dynamic runbooks can also be used for metrics. For example, if you see an increase in table space usage, you might want to create a runbook to proactively check or add space before the usage hits your threshold limits and causes an incident to occur. We'll also expand the use of runbooks in other areas in Enterprise Manager. To create a runbook, start from the incident or metric on which you want to build the runbook. This carries over the details or context of the incident into the runbook and can be used to build and test the runbook steps. Next, add the runbook steps, which we'll discuss in a minute, and then test your steps against the incident context. Finally, when the runbook is ready, publish it for general use. When an incident occurs, your IT ops team can go to Incident Manager and locate your runbook and start a runbook session using your runbook. Then simply execute the steps in the runbook until completion. If your runbook was developed for a metric, then they would find and use the runbook from the Targets All Metrics page. Now let's discuss the type of steps you can use in a runbook. The Note step can be used to provide general instructions. You can format it using Markdown syntax. You can also link to any MOS note or any website or any Enterprise Manager page. Linking to any EM page opens up all of EM functionality for use in your runbook. If you have conditional logic in your runbook, you can also include a quick link to jump to any step in the runbook. The target SQL step is used for running queries, DML, or DDL against a target database. To execute the SQL, it uses named credentials, which can be configured with a PAM or privileged access management provider such as CyberArk. The repository SQL step is used to run queries against EM repository views. The metric data step is used to show metric data in a time series chart. You can show the metrics for the target of the runbook or any related targets. The OS command step is used to run synchronous OS commands or scripts against the host target or the target's host, such as the host of the database. It also uses named credentials, which can be configured to integrate with the PAM provider. Now let me show you a previously recorded demo of using and creating dynamic runbooks. This is a demo of using dynamic runbooks for an incident. In Incident Manager, we see an incident that the FRA, or Fast Recovery Area, is getting full. We maximize the incident view and start a runbook session using the Fast Recovery Area Triage Runbook. It opens a new tab and we see the context of the incident shown at the top. Now let's execute each step of the runbook. The first step is Overview and Prerequisites. Here we see that the runbook can be used to triage and resolve FRA incidents. Prior to beginning, it reminds me to make sure that I have access to the named credentials for the target database and to use the named credential values for the steps that require it. Once I'm done reading this, I can click the step to mark it done. Next step, I click on the play button to execute the step. Here it tells me to review the metric data for the FRA metric and note if there is an increasing trend. I do notice an increasing trend. I can jot down my observations by clicking on the comment icon, note down my comments, and then save it. Step 3, it tells me to run this step to check if the FRA size of the database is set to at least 50 gigabytes. I also notice a gear icon instead of a play icon. Clicking on it, It asks me to specify the name credentials for the database, which I specify, and then I save it. Now the gear icon has changed to a play icon. So every time you see a gear icon, it means input is required. Clicking on the play icon, it tells me that the FRA size of this database is 8 gigabytes, which is less than the expected 50 gigabytes. Step 4 tells me that if we need to increase the FRA size, before increasing the size, first identify the file system used by the FRA. Clicking on this step shows me the file system used. For step 5, it tells me to check the file system for enough free space to increase the FRA. Clicking on the gear icon, I am prompted to specify host credentials, which I then save, and now the gear icon has changed to a play icon. Clicking on the play icon, it shows me the space available in the file system, so yes, I do have enough space to increase the FRA size. On step 6, I execute the step to increase the FRA size to 50 gigabytes, and it tells me it was successful in doing so. On step 7, I click the step to verify the FRA size, which I do. And finally, the last step, which is step 8, is a success criteria step, and it tells me that all of the steps that I've executed previously should have resolved the incident. So I can mark this step as done. At the end of running all of the steps, I can mark the runbook session as done. And it reminds me that when I mark it done, I can no longer rerun the steps, but can view the details. I click OK. Here's a demo of creating a dynamic runbook for an incident. In Incident Manager, locate the incident for which you want to create a runbook. Then in the Runbook Session section, click on Create Runbook. The Create Runbook UI opens up in a new tab. Notice the context of the incident is at the top and is also provided in the runbook variables you can see in this right panel. You can use any of these runbook variables as part of your runbook steps. Now let's give the runbook an appropriate name. The first step is Overview and Prerequisites. Here you give a short description of the purpose of the runbook and any prerequisites required. I'd like to include a prerequisite about target name credentials, but I don't want to hard code the target name. Instead, I'd like to use a variable that contains a target name so that this runbook can be used against any database target. Filtering the list of variables by the word target, we see variables related to the target, and we see the variable aura_target_name that contains a target name, and this we can use in our first step. We expand the area of step 1, and then we type out the overview of the runbook and instructions to make sure that they have name credentials as prerequisites. We can click on the eye icon to review the markdown syntax we can use. For example, we see that 2 asterisks can be used for bold text, which we added to our step. Then we can save the step. The save step shows us what the users of the runbook can see. Now we can add our next step, which is a metric data step. This step is used to show metric time series in a chart. First, we add a step title, and this step title is that we want our users to review the metric that triggered the incident. Next, we add instructions. Notice we can add another variable aura_metric_name to this step, which will be dynamically substituted when the runbook is executed. The body of this step is already pre-populated with the target name and the metric of the incident. It also has a default time range which we can edit. Let's change the start time of the time period shown in the metric chart to EVT_time minus 1D, which means 1 day before the event of the incident occurred. And then we can click on Done. Next, we can click on the Run step to verify the step. And once we verify that this is the output that we desire, we can click on the Save step to save it. Now let's add a target SQL step. In this step, we will check the FRA size. Let's add appropriate step title, as well as instructions, and the corresponding SQL query. For the name credentials, I'll specify credentials that will be used. I could have chosen to make the user enter their own name credentials in a runbook session. And to do that, I would first create a variable to contain the name credentials and use that variable instead of hard-coding credentials. But for this demo, I'll just specify the credentials. Now I can run the step and verify the output. The output is what I expect, so I click to save the step. At this point, I can continue adding more steps to the runbook. For this demo, let's assume I've done that and I am now ready to publish the runbook. To do that, I click on the Runbooks link, locate my runbook, and go to the Actions tab and select Publish. I choose the option to keep a draft in case I want to edit this runbook later on. Then I click on OK, and now the runbook is published and available for general use. Let's recap our solution for managing alert fatigue. First, identify events that are actionable and create incidents for these events. Second, when creating incidents, use event compression policies to reduce incident volume. Finally, create and use dynamic runbooks to capture your subject matter expertise in resolving incidents, or even use it on metrics to prevent impending issues into becoming incidents. Making this expertise available in an executable runbook for your ops teams reduces trial and error approaches and enables a more streamlined way to triage and resolve incidents. Thanks for attending our session today. Here are additional resources to learn more about Enterprise Manager.